Hello everyone, welcome to Standard 7 Physics class. Today we are going to discuss about the characteristics of sound waves. When we hear sounds around us, we hear soft sound and loud sound. Some sounds are soft. The sound what we hear around us are soft or loud. Some sounds are soft and some sounds are loud. Some sounds we hear shrill while some sound appear pleasant to us. Some sound make us feel annoyed. The two major characteristics make sound different from each other. These characteristics are frequency and amplitude. These are the two characteristics of sound, frequency and amplitude. So frequency, first to discuss about frequency. What is frequency? Frequency tells us how often an event occurs. Suppose you are ringing a bell. The number of times you ring the bell per unit time is called the frequency of your ringing the bell. If you ring the bell 10 times in 1 minute, then we can say that frequency of a ringing bell is 10 beats per minute. If you already know that each sound wave consists of a rarefaction and compression, if you count the number of compression or rarefaction that crosses a particular region per unit time, and we will get the frequency of the sound wave. A sound wave with more number of compressions and rarefaction in a region at a time will have higher frequency and vice versa. Look at this picture. You see, in the above picture, it is less frequency. It occurs 1, 2, 3, 4, 5. 5 rarefaction, 5 compression and 4 rarefactions. But in the picture given below, it has 1, 2, 3, 4, 5, 7 compression and 6 rarefaction. Therefore, it is a more frequency and high pitch sound, less frequency and low pitch sound. Frequency is interpreted by our brain as pitch. So higher is the frequency, higher is the pitch. Remember it. Higher is the frequency, higher is the pitch. Corresponding to that sound, the lower is the frequency, lower is the pitch of that sound. Pitch of a sound seems to change as the source approaches or moves away from the listener. This is known as Doppler effect. Now the next characteristics of sound is amplitude. Amplitude is the magnitude of maximum displacement of each particle from its mean position. Amplitude depends on the force with which the object is made to vibrate. If we strike a drum with lesser force, that is, if we strike a drum lightly, then the less number of air particles will get displaced from their main position. Thus, the amplitude of the sound produced will be low. However, if we strike the drum with more force, then large number of air particles would be displaced from their mean position. Thus, the amplitude of the sound produced will be high. Amplitude of a sound is directly related to the loudness of the sound. The greater is the amplitude, louder is the sound. Remember this point. The greater is the amplitude, louder is the sound. The lower is the amplitude, softer is the sound. In this picture, less amplitude, so soft sound. Here greater amplitude, so louder sound. A sound wave can also be represented by density pressure graph. In that, compression is the region where particles are crowded together, are represented by upper portion of the curve. These are the compression. On the other hand, the rarefaction region where the particles are spread apart are represented by the lower portion of the curve. This is the mean position. Upper portion represents compression, lower portion represents rarefaction. This is a time, density and pressure time graph. The density pressure graph of different frequency and amplitude are shown below. High frequency and high pitch. Here low frequency, so low pitch. This is the low amplitude sound. So low amplitude means softer sound. High amplitude means louder sound. Let us perform an activity to show that sound requires a medium to propagate. So we need a bell jar, a vacuum pump and a mobile phone. What we have to do, take a bell jar connected to a vacuum pump. Now place a mobile phone in the bell jar. A mobile phone is placed inside the bell jar. Now ring the mobile phone using another phone. Now pump out the air from the bell jar using a vacuum pump. Ring the mobile phone using another phone again. So what we will observe? You will be able to hear phone ringing when the air is present inside the bell jar. And you will notice that the ringing sound of the mobile phone becomes feeble and finally disappear as more and more air is pumped out of the bell jar. When the air pumps out of the bell jar, the sound is not audible to us. So we conclude that sound cannot travel in vacuum. It requires a medium to propagate. In this chapter, next is the reflection and absorption of sound wave. First, we discuss about reflection of sound. You know the reflection of light. Similarly, sound also gets reflected. When the sound wave strikes a hard surface, they get reflected. When the size of the room is small, then the sound waves which reach our ears directly and the ones which gets reflected from the walls reach our ears at the same time. As a result, we hear only one sound. But when the sound gets reflected from a surface which is far away from the source of sound, we hear two sounds. We hear the first sound due to the sound waves that reach our ears directly. We hear the second sound because of the sound waves get reflected from the distant surface and reach our ears slightly later. This sound that we hear again is called echo. So what is echo? The sound, the reflected sound wave. This sound, echo, is used in navigation, fishing, etc. It is produced only when the listener is at least 70 meters away from the reflecting surface. The distance between the reflecting surface and listener should be at least 70 meters. Hard materials such as metallic sheet, hard plywoods, plain mirrors, tiles, marble slabs, etc. are good reflectors of sound. Let us perform an activity to show that sound obeys the laws of reflection. So requirements: 2 hollow cardboard tubes, wooden plank, an alarm clock, a ruler and a protractor. Okay, first set up the cardboard tubes and the wooden plank as shown in this figure. Place the alarm clock near the end of one tube and place ear at end of other tube. Adjust the tube so that the ticking sound of alarm clock can be heard loudest. The sound coming from the alarm clock and reaching towards the wall represents incident sound. Here this sound is the incident sound. And the wooden plank, this is the wooden plank, represents the normal, and the sound coming towards the ear represents the reflected sound. This is the reflected sound. This sound. Using protractor, measure the angle of incident and angle of reflection. You will observe that the loudness of sound heard through this second tube is maximum when the angle of incidence is equal to the angle of reflection. The incident sound in normal and the reflected sound all lie in the same plane. So we conclude that sound obeys laws of reflection. Now, absorption of sound. When sound waves strike soft surfaces, they get absorbed. This property of sound is used for soundproofing. The walls of movie theater are lined by soft materials like foam. This lining absorbs the sound and provides sound isolation. Porous and soft materials like thermocol, carpet, paper, clothes, etc. are poor reflector or good observers of sound. Now, speed of sound in different media. We know that sound travels through all three media, that is solid, liquid and gases, but sound does not travel at the same speed in all three media. Sound travels faster in denser mediums such as water than lighter mediums such as air. Therefore, we can conclude that sound travels fastest in solid, slower in liquid, and slowest in the air. The speed of sound in some medium is listed in this given table. You see, speed of sound in iron is 5000 meter per second. Speed of sound in glass is 5640 meter per second. Speed of sound in water is 1440 meter per second. Speed of sound in alcohol is 1210 meter per second. Speed of sound in air is 340 meter per second. So this is all about the chapter sound. So with this chapter is completed. So prepare better for your examination, and if you have any doubt in any question and in understanding the concept, you post your query on the group. I will try my level best to make you understand the concept and also help you to clear your doubts. So thank you for watching my video.